Good morning. The title of this study is Heat Transfer Enhancement in Horizontal Double Pipe Energy Source System by using internal fans. The work was done by me, Nesrine Boulaktout, and Professor Al-Hassan Mazaj. As we can know, solar thermal energy as renewable energy is unstable with different time, which can limit its application. So recently, thermal energy storage systems by using latent heat thermal energy storage system have gained a greater attention from a viewpoint of global environmental problems and the energy efficiency improvement. However, the problem of fast-change materials that they have low thermal conductivity, which can limit its application as a charging and discharging process should be fast enough. Therefore, various methods are used to remedy the poor thermal conductivity, such as using a porous medium or metal foam, or even adding nanoparticles. A more effective method has been used for performance improvement of latent heat thermal energy storage system is the insertions of fines. This method is simple, easy, effective, and lower cost. So the main objective of this study is to investigate the heat transfer enhancement in horizontal double pipe energy storage system by using internal fines. The problem consists to study the melting process inside annulus thermal energy storage systems. We impose house temperature to the inner cylinder while we kept the outer cylinder as adiabatic. At first time, the PCM is a solid state and we use NCASAM as a fast change materials. Four systems were studied with two different phase number and two different phase orientation. The results show that at early stage, a thin melting layer was formed for all cases and the molten portion tightly surrounds the phase and the inner tube. The melting front is uniform for all cases and the dominant heat transfer at this stage is by heat conduction. After a while, for two fine cases, we can observe the appearance of waviness at the upper space of the annulus for case A2. For case A1, the presence of the fine at lower part of the annulus shows significant effect on the melting rate. Natural convection is well developed unlike in horizontal phase case, where the fine arrangement prevents the movement of the melt flow. A non-uniform melting front was also shown in 8 fine cases as a result of onset of heat convection. At final stage, we can see the thermal stratification at the lower part of the annulus. However, the complete melting time of PCM in A1 case is about 16.5 minutes, while it's 42.25 minutes in A2 case, meaning that the melting time may increase by 2.5-fold as the fine orientation is changed. On the other side, almost identical results were recorded for 8 fine cases. So we can conclude that at early periods, the main heat transfer mechanism is by heat conduction. However, after that, natural convection heat transfer plays a key role. And fine orientation exhibits a big impact on the melting time for 2 fine cases, while its effect is insignificant for 8 fine cases. Compared with case A2, the melting time is about 2.5 folds shorter in case A1, due to the orientation of fines where the vertically downward fine placement is presented in case A1 and it promotes the melting of the solid portion of PCM remaining at the lower region of the annulus and prevents the stratification of the temperature. Thank you for your attention.